Hello, James Torres, Exercise 007, and we're gonna convert the following IP address to binary numbers. So first problem is 201. I need space, period, 17, period, and 29, period, and 4. Okay, so we need a converting chart. So 128 divided by 2, divided by 2 is 64, divided by 2 is 32, divided by 2 is 16, divided by 2 is 8, divided by 2 is 4, divided by 2 is 2, 2 is 1. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. That's an octet. Convert it into binary numbers. 201. So 128 is less than 200, so we can use it. Plus 64 would be 92, so we can still use it. 192 plus 32 would be too big, so we shouldn't use it. Turn it off. Plus 16 would be too big, but plus 8 would be okay. So 192 plus 8 would be 200. I think 200, so we can use these. This one, but we only need one more, 201, so we can't use this. We can't use this either, but we can use this. So 1100, 1100, 1001 is our answer. And for 17, we can't use 0. We can't use 128. We can't use 64 because it's too big. We can't use 32, but we can use this. So 16. So we only need one more to get 17. So we can't use 8. We can't use 4. We can't use 2, but we can use 1. So this one is 00010001. And next one is 29. So 128 is too big. 64 is too big. 28 is also too big. 16 is okay. 16 plus 8, still 24 within 29, so we can use it. So 24 plus 4 would be 28, so we can still use it. But if we add 2, it'll be 30. It'll be too big, so we can't use it, but we can use 1. Okay, 0, 0, 0, 1, 1, 1, 0, 1. Four should be easy, so we already have 4 here, so we just need to use that. 1, 0, 0, so this one is 0, 0, 0, 1, 2, 3, 4, 5, 1, 2, 3, 8. Okay, so the answer for A is this one right here. Okay. There. Okay, go to question B. Next is 192. 192. Point 168. Point 1. Point 1. Okay, we'll start with 192, 128, 64, 32, 16, 8, 4, 2, 1. So 192, we know that 192 is 128 plus 64 is 192. The rest would be turned off. 0. So 1, 1, 1, 2, 3, 4, 5, 6. So that'll be an octet. The answer for that. So for 168, we can use 128, but we can't use 64 because it's 192. It'll be too big. Plus 32 would be 160, so we can use it, but we can add 16, but we can add 8, so that would make it equal to 168. Okay, So we can't use these things anymore. So the answer is 1 0 1 0 1 0 0 0. Now for 1, it's very easy. We have 1 here, so we only need to use this part of the octet. So 0, this one is 0, this one is 0, this one is 0 0 0 0 0 1. So we have 1 2 3 4 5 6 7 1. The same answer for this. 0 0 0 0 0 0 0. 6 7 8. So this is the answer for question B. You can pause it to check later. So we will go to question C. Question C is 172.0.0.0. So we need 172.0.0.0 using the same technique. 128 64 32 16 8 4 2 and 1. So we'll solve this one first. So 128 can be used because it's below it is below 172, and if we add 64, it'll be 192, so it's too big, so we can't use it. But if we add 32, it'll be equivalent to 160, so it's still okay. But if we add, so 160 plus 16 would be too big. If we add 8, it'll be 168, so it's still okay. If we add 4, it'll be equal to 172, so we can use this, but we can't use these things anymore. So the answer is this 1 0 1 0 1 1 0 0. And for the rest, all the binaries off because it's 0, so it'll be 0 0 0 0 0 0 0 0. Same here. The binary for this is 0 0 0. Okay, so that is the answer for question C. Okay. There. So now we're going to go to question number 2. We're going to convert this 4-octet binary into decimal. So we're just going to use the same thing earlier. Okay, so to convert, we have to copy it. Sorry. 1 1 0 0 1 1 1 and 0 0 0 0 0 1 1 1 and 0 0 0 1 1 0 1 0, then 1 0 1 1 2 3 4 5. So we're gonna convert these things to decimal. Okay, so we'll need our chart. 128 64 32 16 8 4 2 1 1 2 3 4 5 6 7 8. an octet. So let's see these, tally them down. So 1 0 1 1 1 1. Oh wait, 0. This one's 0 and this one's 1 1. Okay. So let's see. 128 plus 64 is 192. Plus 8 would be 200. Plus 4 would be 204. Plus 2 would be 206. Plus 207. Let's recheck. 192, 200, 204, 206, 207. Okay, so this one is 207 here. And next one is this. So 0 0 0 0 0 1 1 1. So these are all off, so we'll start here. 4 plus 2 is 6 plus 1 is equals to 7. So this one is 7. And the next one is 0 0 0 1 1 0 1 0. So off, 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 on. So 16 plus 8, 24, plus, this one's off, 24 plus 2, it's 26. 26. This one is the last one. 1 0 0. Start 128 plus 32 is 160. So the answer is 160. So this is the answer for question number 2. To convert this one. Okay, go to the next page. Okay. Oh, here. So network address. So I think this one means 0. I assume this is 0, not, or 1. I think it is 0. This is for the host, I think. Okay, and so the question here is, what is the network address in binary? Okay, so we're gonna convert this then, the network address, into binary. Let's start 192.168.1-1 dot dot dot. So we need our handy dandy converting chart. 32 16 8 4 2 1. So we're gonna convert 192 is 128 plus 64 is already 192, so the rest would be 0 0 0 and 0. Sorry, 1 1 1 2 3 4 5 6 6. Okay, for 168 we need 128, not this one. Plus 60 would be 160. 128 plus 32 is 160, so it's still okay. Too big if we add 16, but if we add 8, it'll be equal to 168. Use this, we can't use these things anymore. So this is the answer. 1 0 1 0 0 1 1 0 1 0 1 0 0 0 1 2 3 4 5 6 7 8. Okay, that's the answer there. And for 1, be easy. These are all off, 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 off. You only need this one here. So 1 2 3 4 5 6 7 1. Same thing. Common sense applies. 1, 2, 3, 4, 5, 6, 7. So this is the binary answer of the network address. The binary conversion of our network address 192.168.1.1 is 110 here. 11000000101010101010 and so on and so forth. Okay, next question is, what is the subnet mask in binary? Well, I changed this to 0, so I would assume that. Now, if all these, the chart, we're gonna use a chart to 255, 255, 255, and 0. So 128, 64, 32, 16, 8, 4, 2, 1. So we all know that 255 is when everything is on. So 128 plus 64, 192 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1 would be 255. 8. The same for this one. 1, 2, 3, 4, 5, 6, 7, 8. 2, 3, 4, 5, 6, 7, 8. 0 would be 0, 0, 0, 0. 4, 5, 6, 7, 8. I think this is the answer. And for C, what is the prefix length for subnet mask? I think since we have 8 octets on plus 8 octets on plus 8 octets on would be this one, 24/24. And letter E, in the network address 192.168.1.1, underline the network portion and encircle the host portion. So 192.168.1. So I think that this part is for the network. Okay, this is the network's portion, and the last one is for the host portion. Okay. Oh, sorry, I should encircle it there. Host portion. And to answer some questions, why do we need to convert the decimal value to binary numbers? It's important to know how to convert these things, since the computer only understands binary numbers, and if we can do this, it's easier for us to know and understand how the computer works. And more complex detail would be for subnetting. It's used for subnetting. And why all computing devices have an IP address? Is it possible to have a similar IP address among end devices? Explain yourself. It is not possible to have a similar IP address, since they would have an IP conflict. From all the networking laboratories we did before, we found that out already. And why all computing devices have an IP address? Well, because that's a way to locate the device in the network. Without an IP address, it cannot be located. So it needs a unique IP address, and it also needs to have an IP address for itself. Okay, number 3, what is the importance of the subnet mask? Well, the subnet mask is important for us to know or divide the network in usable parts, and also to know which part is the network, which part is the broadcast address, and which part is for the host part. And what can you conclude from this activity? Well, I can conclude that understanding how to read a network address and the subnet mask is very important if you want to be a successful network administrator. Thank you and God bless.